Welcome back to Hardware Unboxed. Now, recently I put together a massive CPU and GPU scaling benchmark based on AMD's Zen 3 series, and while the results weren't terribly surprising, they were useful, and thankfully many of you agreed. I also mentioned that those boring results would pave the way for more interesting benchmark videos, and today we have one such video. I thought it'd be interesting to see how AMD's 6-core Ryzen processors compare using a range of quality settings, resolutions, and GPUs, and I wasn't wrong. The results are extremely interesting, and not just for the reasons I thought they would be. I've stumbled upon some very strange results, and some of this stuff we've sort of seen in the past, but I've never really had the hardware required to really dig in. Anyway, there is a lot of results to go over here, so I want to jump into it as quick as possible. For this one, I really wanted to see how the Ryzen 5 1600X, 2600X, 3600X, and 5600X compared in half a dozen games using the GeForce RTX 3090, RTX 3070, Radeon RX 5700 XT, and 5600 XT, using both the ultra and medium quality presets at 1080p, 1440p, and 4K. Previously, a few people were confused why I didn't use the 6900 XT and 6800 in place of the RTX 3090 and RTX 3070. Now, there are two reasons for this really. One being that most of you are really interested in buying a GeForce 30 series GPU, and most of you have or are trying to, at least according to a recent poll. Also, it really shouldn't matter as they do represent a very similar performance tier, though as you're about to see, my decision to use the Ampere GPUs has led to the discovery of some very interesting results. Finally, for the test system, each CPU has been tested using 32GB of DDR4 3200CL14 memory in a dual rank, dual channel configuration on the Gigabyte X570 Aorus Extreme, and cooling them is Corsair's iCUE H115i Elite. And finally, apart from loading XMP, no other changes have been made to the BIOS. Okay, let's get into the results. Starting with the Cyberpunk 2077 data using the ultra quality preset at 1080p, the results are mostly as expected. Using the Radeon 5700 XT or 5600 XT, all four CPUs delivered the same level of performance, though we are looking at sub 60 FPS frame rates even with the 5700 XT. Then when stepping up to the RTX 3070, we see that the 5600X outperformed the 3600X by an 8% margin when comparing the 1% low data, 10% faster than the 2600X, and 24% faster than the 1600X. Those margins only increase with the RTX 3090. The 5600X is now 28% faster than the 3600X when comparing the 1% low results, 43% faster than the 2600X, and a massive 62% faster than the 1600X, which limited the average frame rate performance to around 75 FPS. Now, you might have noticed that the 1600X was a frame or two faster with the RTX 3070 when compared to the 3090, and while that's typically deemed to be within the margin of error, as you're going to see soon, there might be a little bit more to this. Now, by lowering the quality preset, we're allowing the GPUs to render more frames, which does increase the CPU load, though you can also reduce the CPU workload as there's less information each frame to calculate, so it's a different kind of workload. As a result of the higher frame rate, the 1600X does slip behind with the 5700 XT, at least when comparing the 1% low performance, though this wasn't the case with the 5600 XT. We also find that the game is now largely CPU bound using the Ampere GPUs, as the RTX 3070 and 3090 performance is very similar. Using the 3090, we see that the 5600X is 19% faster than the 3600X, 41% faster than the 2600X, and 58% faster than the 1600X. So some rather large performance gains there over previous generation Ryzen architectures. Then, jumping up to the 1440p resolution, which increases the GPU load more than it does CPU load, sees the game become primarily GPU limited, at least when using an RTX 3070 or slower. When looking at the 1% low data, we see that the 5600X is up to 12% faster than the 1600X when using the RTX 3070. So not a huge difference when comparing the first generation Ryzen to the latest generation, but there is still a difference here, and that's not something we saw with the 5700 XT, for example. Then once we jump up to the RTX 3090, we see up to a 27% performance difference between the fastest and slowest 6-core 12-thread Ryzen CPUs tested, though there was just an 8% difference when comparing the average frame rate. Now, using the medium quality preset at 1440p sees some variation in the 1% low performance when using the RTX 3070. Here the 5600X was 7% faster than the 3600X, 10% faster than the 2600X, and 16% faster than the 1600X. That said, the margins really only became noteworthy when using the RTX 3090. Here the 5600X was up to 14% faster than the 3600X, 36% faster than the 2600X, and 63% faster than the 1600X, which is obviously a massive margin. Though again, it will require extreme GPU horsepower for that difference to be realized, at least in today's games. Climbing up to 4K virtually eliminates all performance margins, even when using the RTX 3090. The 5600X was only up to 8% faster than the 1600X, and that's a 2 FPS difference while the average frame rate was identical. Then using the medium quality settings at 4K, this sees all 4 CPUs delivering the exact same level of performance using the RTX 3070, 5700 XT, and 5600 XT. That said, the 1600X does suffer a little bit with the RTX 3090, and here the 5600X was 17% faster when comparing the 1% low data. Now let's move on to the Rainbow Six Siege results, as this is where things start to get rather complicated. At 1080p using the ultra quality preset, the results using the 5600 XT and 5700 XT are pretty much what you'd expect to see. The game is heavily GPU bound, and even the old Ryzen 5 1600X can max out these GPUs. However, as we move to the Ampere GPUs, a few strange observations can be made. Firstly, the Ryzen 5 1600X is slower using either the RTX 3070 or 3090 when compared to what we see with the 5700 XT. So how is that possible, you might be thinking? I believe the answer is two things. One, it's the NVIDIA driver, and two, it's the Ampere architecture. NVIDIA's driver has a high core dependency for multi-threading workloads, like what we see in DirectX 12 and Vulkan titles. CPU architectures that feature a non-coherent cache, like what we see with Zen, Zen Plus, and Zen 2, will need to be optimized for. And I believe this issue is less pronounced with Zen Plus due to its cache optimizations that led to the 2600X being faster overall, and therefore provides a less CPU-bound scenario. Another oddity in the results here is the fact that the Ryzen 5 1600X was able to deliver a slightly higher frame rate with the RTX 3070 when compared to the 3090. We're only talking about a 3% increase, but it was repeatable. I'm just guessing at this point, but I believe the wider design of the G0102 die is creating more CPU load as the driver scheduler works harder to feed all those extra cores. I'll need to look into this by testing with more hardware configurations to really work out what's going on, but this is how it appears based on what I'm seeing here. And whatever the case, it's fascinating to find that the Ryzen 5 1600X is able to deliver 7% more frames with the 5700 XT when compared to the RTX 3090. As for the RTX 3090 results, here the 5600X was 32% faster than the 3600X, 68% faster than the 2600X, and an insane 97% faster than the 1600X, seen when comparing the average frame rate. Now, the funny results seen with the Ampere GPUs previously using the ultra-high preset are even more pronounced with the lower quality medium settings. Again, if we look at the Ryzen 5 1600X results, we see that this CPU is able to roughly max out the Radeon 5600 XT with 272 FPS on average, and that figure was boosted by 18% with the 5700 XT to 321 FPS. However, by using what is technically a faster GPU with the RTX 3070, we find that the 1600X performance declines by 9% to 293 FPS, and then a further 6% with the RTX 3090 to 274 FPS, basically the same level of performance seen with the 5600 XT. This issue is less severe with the faster 2600X, but still we are seeing a situation where going from the 5700 XT to the RTX 3090 does little to improve performance. The issue is largely solved with the 3600X, which saw a rather large 25% performance increase when jumping up from the 5700 XT to the RTX 3070, yet once again we do find that the higher core count RTX 3090 slowed the 3600X down by a 5% margin, dropping the average frame rate from 435 FPS to 413 FPS, and naturally you'd expect the opposite. In fact, the only CPU that scales correctly here is the 5600X and its unified L3 cache. Here we're looking at a 26% performance boost when moving from the 3070 to the 3090 and a 65% increase from the 5700 XT. Now, by drastically increasing the GPU load at the 1440p resolution, we find that scaling returns to normal, and here we're looking at similar CPU performance across the board when using the RTX 3070 or slower. That said, the R5 1600X did drop some performance when upgrading to the RTX 3090, though that wasn't the case with the 2600X, which saw a 14% increase. The 5600X and 3600X were both fast enough to max out the RTX 3090, and that meant the new Zen 3 processor was 23% faster than the 2600X and 44% faster than the 1600X. Lowering the quality preset to medium at 1440p sees the 1600X trail the newer Zen parts, and this just goes to show how significant the refinements made with the Zen Plus architecture really were. Then once we reach the 4K resolution, there is very little to talk about in the way of performance differences. Basically, we're heavily GPU limited here, and even the 1600X comes close to maxing out every GPU tested. We're seeing much the same with the medium quality settings as well, so not much more to talk about here, so let's move on to the Horizon Zero Dawn results. Okay, so time for some more odd results. Once again, starting with the 1080p ultra quality data. Again, the Radeon results are pretty much what you'd expect to find. All 4 CPUs maxed out the 5600 XT, while we see a small performance improvement for the 3600X and 5600X using the 5700 XT. However, it's again the 1600X results using the Ampere GPUs that are confusing relative to what we see with the 5700 XT. Whereas the 1600X averaged 93 FPS using the 5700 XT, it was good for just 87 FPS with what should be the faster RTX 3070, though it did peak at 98 FPS using the RTX 3090. The 2600X, on the other hand, was fast enough to mitigate the overhead with the Ampere GPUs, delivering virtually the same performance with the 5700 XT and RTX 3070 to see a 12% uplift with the RTX 3090. The 1080p results are even more extreme using the medium quality preset. Here we're seeing a bigger performance difference between the 1600X and 2600X when compared to the 3600X and 5600X using the 5700 XT. But that's not the most interesting thing we're seeing here. Again, the Ryzen 5 1600X results are truly bizarre, as this CPU was good for 118 FPS on average with the 5700 XT, yet just 98 FPS with the RTX 3070 and 109 FPS with the RTX 3090. A similar thing is seen when using the 2600X. It was good for 123 FPS with the 5700 XT, but just 109 FPS with the 3070, though it did jump back up to 125 FPS with the 3090. In fact, even the 3600X was faster with the 5700 XT when compared to the RTX 3070, though it was 8% faster with the 3090. Now you'd think based on that the 5700 XT was in fact faster than the RTX 3070 under these conditions, but technically it's not, as the 5600X was 11% faster using the Ampere GPU. Now, if we look at the CPU limited RTX 3090 results, we see that here the 5600X was 23% faster than the 3600X, 50% faster than the 2600X, and 72% faster than the 1600X. Now, as was the case with the Rainbow Six Siege results, we again find that increasing the resolution to 1440p, which makes the testing far more GPU bound, sees these strange results between the RDNA and Ampere GPUs with the older Ryzen processors disappear. All 4 CPUs managed to max out the 5600 XT with only minor performance differences seen with the 5700 XT. Then we see a universal performance uplift when moving to the RTX 3070, with further gains for all processors seen with the RTX 3090. Scaling with the RTX 3070 is fairly consistent. Here the 5600X was 4% faster than the 3600X, 10% faster than the 2600X, and 19% faster than the 1600X. The 1440p medium quality margins are fairly similar to what we saw using the Ultra preset. All 4 CPUs came close to maxing out the 5700 XT, while we start to see a noticeable difference in performance with the RTX 3070. Then, by the time we reach the 3090, the 5600X is seen to be delivering 21% more performance than the 3600X, 37% more than the 2600X, and 55% more than the 1600X. As you'd expect to see, we're almost entirely GPU bound at the 4K resolution. The 1600X trailed slightly with the Ampere GPUs, but outside of that the performance was the same for the Zen Plus, Zen 2 and Zen 3 processors. Using the medium quality settings at 4K saw some variation in the results using the RTX 3090. Here the 3600X and 5600X were just 4% faster than the 2600X and 9% faster than the 1600X. Next up, we have the very CPU demanding Shadow of the Tomb Raider, and here we find that even with the 5600X, the Ryzen 5 1600X is dropping a few frames, particularly when looking at the 1% low performance. This is slightly more pronounced with the 5700 XT, and here the 5600X was up to 17% faster. The 1600X did see a small reduction in average frame rate performance with the Ampere GPUs, though there was also a small uptick in 1% low performance. The 1600X, 2600X, and 3600X all limited the performance of the 3090 and 3070, as the 5600X was 16% faster than the 3600X when using the RTX 3070, and 33% faster with the 3090. Using the medium quality settings at 1080p resulted in very similar performance margins, and again the 1600X was slightly faster using the 5700 XT when compared to the Ampere GPUs. The same was also true for the 2600X. Then with the RTX 3090 we see that the 5600X was 28% faster than the 3600X, 50% faster than the 2600X, and 68% faster than the 1600X. Now, increasing the resolution to 1440p helps alleviate the CPU bottlenecks seen at 1080p, and now all 4 Ryzen processors are able to get the most out of the 5600 XT and 5700 XT. We're also seeing a situation where the 1600X and 2600X are significantly faster when paired with the RTX 3070 opposed to the 5700 XT. The game was also GPU limited using the RTX 3070 when paired with either the 5600X or 3600X. The medium quality results also saw no real difference in performance between the various 6-core Ryzen processors when using the 5700 XT or 5600 XT. We do start to see a bit of separation with the RTX 3070, and then once we jump up to the RTX 3090, the newer Zen 3 processor is much faster than the previous generations. Once again, we see that jumping up to the 4K resolution makes the testing far more GPU limited, though the mighty RTX 3090 is still powerful enough to see some variation in CPU performance, especially when looking at the 1% low data. Quite incredibly here, the 5600X was still up to 18% faster than the 1600X, 13% faster than the 2600X, and even 10% faster than the 3600X. And the 4K medium results are very similar to what we saw when using the ultra quality preset. It's really not until we jump up to the RTX 3090 that we start to see a noteworthy difference in performance. Next up we have Watch Dogs Legion, and again we'll start with the ultra quality 1080p data. Here we're looking at a hard GPU limitation using both the 5600 XT and 5700 XT, and this time moving to the RTX 3070 only had a very minimal negative impact on performance for the 1600X. That said, with the RTX 3070, it was only the 5600X that was able to find the limits of the GPU under these test conditions. Okay, so testing at 1080p again, but this time using the medium quality preset, results in this mess. The 5600 XT and 5700 XT results are fairly easy to make sense of. The 1600X and to a degree the 2600X aren't able to max out the 5700 XT. Then with the faster 5700 XT, the 1600X and 2600X trail the 3600X and 5600X quite significantly, though you could argue that the performance overall was very acceptable. Still, with this now mid-range GPU, the 5600X was 17% faster than 2600X and 28% faster than the 1600X. Again, where the data gets messy is when we compare the 1600X and 2600X 5700XT data with the RTX 3070. In fact, here you can also include the 3600X. Quite incredibly, the 1600X and 2600X were 20% faster when paired with the 5700XT, and the 3600X was 17% faster. It's quite incredible how much better these Ryzen CPUs perform with a Radeon GPU under these test conditions, and the margins are very similar even with the RTX 3090. It'll be quite interesting to go back and add the 6900 XT and 6800 to this data, and that's something I hope to do soon. Increasing the resolution to 1440p with the ultra quality settings increases the GPU bottleneck with the RTX 3070, and here the 3600X and 5600X are basically identical in terms of FPS performance. Even the 2600X wasn't that far behind, though the 5600X was up to 23% faster than the 1600X. Then if we look at the RTX 3090 data, we see that the 5600X was 14% faster than the 3600X when comparing the 1% low data, 37% faster than the 2600X, and 54% faster than the 1600X. Again, the medium quality preset introduces some strange anomalies into the results, though we have seen this in other games under certain conditions. Here we're again seeing superior performance for the 1600X with the 5700 XT, opposed to what should be the faster RTX 3070 GPU. Other than that, the results do look fairly typical. We're GPU limited with the 5600 XT and 5700 XT, while we're CPU limited with the RTX 3070 for the 1600X, 2600X, and 3600X. Increasing the resolution to 4K with the ultra quality settings saw Watch Dogs Legion become almost entirely GPU bound. In fact, it was with the RTX 3070 and slower. We did see some small variation in performance with the 3090. Here the 5600X was up to 11% faster than the 1600X. Then at 4K with the medium quality settings, we find the margins open up with the RTX 3090, though the 3600X is able to closely match the 5600X. Then the last game we're going to look at is Assassin's Creed Valhalla. At 1080p using the ultra quality preset, we find the results are fairly heavily GPU limited with the 5600 XT, 5700 XT and RTX 3070. There is a small drop in 1% low performance for the 1600X and 2600X with the 3070, but other than that we are looking at heavily GPU limited results. Then with the RTX 3090, the 5600X was up to 3% faster than the 3600X, 21% faster than the 2600X and 25% faster than the 1600X. Finally, it is worth noting that the 5700 XT is similar to the RTX 3070 in terms of performance due to the fact that this is an AMD sponsored title and is therefore highly optimized for Radeon GPUs. The margins using the medium quality preset really aren't that different. Again, all four CPUs come close to maxing out the 5600 XT and 5700 XT, while we see only a small variation in performance when using the RTX 3070. Then with the 3090, the 1600X and 2600X are limiting performance, while the 3600X and 5600X appear to be maximizing what the 3090 is capable of at this resolution. Jumping up to 1440p with the ultra quality visual settings does allow the RTX 3070 to pull ahead of the 5700 XT, though that's not really what we're interested in here. Rather, it's the fact that all four CPUs are able to max out the 5600 XT, 5700 XT and RTX 3070. We do find the limits of the 1600X and 2600X with the RTX 3090, particularly when looking at 1% low performance. Interestingly, lowering the quality settings with the medium preset helps reduce the CPU load and allows the 1600X and 2600X to deliver better, more consistent 1% low performance when paired with the RTX 3090. This isn't totally unexpected, we have seen this sort of behavior a number of times in the past. Finally, at the 4K resolution, the game became extremely GPU bound, and this was the case for both the ultra and medium quality settings, so not much more to say here. Okay, so some very interesting results there, and some of the testing will warrant further investigation once I get a bit more time on my hands. Anyway, a lot of mixed data, so let's move on to take a look at these 6-game averages. Okay, so the average 1080p ultra data looks pretty normal. On average, across the half dozen games tested, the 4 Ryzen 5 CPUs maxed out the 5600 XT and 5700 XT with only a minor variation in 1% low data with the 5700 XT. Then, as we upgrade to the faster RTX 3070, the 1600X typically saw no real performance improvement. The 2600X only saw a 10% boost, while the 3600X became 23% faster, and the 5600X 31% faster. The margins widened further with the flagship RTX 3090. Here the 5600X was on average 20% faster than the 3600X, 43% faster than the 2600X, and 59% faster than the 1600X. That's basically double the margins seen with the RTX 3070. Now, with the medium quality settings at 1080p, we again see little to no difference between the various CPUs tested. The margins did open up with the 5700 XT, and now the 5600X was up to 17% faster than the 1600X, though it was basically matched by the 3600X. Then, as we saw numerous times, the 1600X and 2600X go backwards in terms of FPS performance when moving to the RTX 3070. In this case, the average frame rate dropped by 15% for the 1600X and 7% for the 2600X. The 1600X, 2600X, and even the 3600X saw very little in the way of extra performance when upgrading from the RTX 3070 to the 3090. Just a 6% uptick in the case of the 3060, while the 5600X gained a further 14% performance. Now at 1440p using the ultra quality settings, we again find that all 4 CPUs were able to max out the 5600 XT and 5700 XT, while we see up to a 15% increase in performance from the 1600X to the 5600X with the RTX 3070. Of course, the real margins are seen with the RTX 3090, where the 5600X was on average up to 9% faster than the 3600X, 23% faster than the 2600X, and 38% faster than the 1600X. The 1440p medium results are fairly similar to what we just saw, though CPU bottlenecking with the RTX 3070 is more evident here. Then, as we saw time and time again, the 4K Ultra performance is very similar across the board with only very small margins for the 1% low performance seen when using the RTX 3090. Those margins opened up a little bit by using the medium quality settings, though if you're running an RTX 3090, chances are you won't be doing so with a first or second generation Ryzen processor. Well, that was an incredible amount of data, and I've got to admit, I'm kind of walking away from this one with more questions than answers. I really want to retest a few of those games with the 1600 XT and 6800, as well as the RTX 2080 Ti, while also including a few Intel CPUs for reference. As for what was learnt here, there are a few interesting takeaways. Firstly, while a massive step forward for AMD, the first generation of Zen wasn't the most efficient architecture for gaming, and while that won't necessarily be news to many of you, it is interesting to see how Zen, Zen Plus, Zen 2 and Zen 3 compared using a range of quality settings and graphics cards. We know, for example, that the Ryzen 5 1600X has aged better than the Core i5 7600K, so it certainly wasn't a bad buy, and if you're somewhat realistic about the hardware configuration, a part like the 1600X is still very respectable even today. Of course, you can test it with an extreme GPU like the RTX 3090 and claim it's pathetic, as the 5600X is often over 50% faster. But as I said, pair it with a more reasonable budget combo like the 5600 XT or really even the 5700 XT, and it does quite well. That said, the RTX 3090 results do help highlight just how far AMD has come with Ryzen in a relatively short period of time. For example, Zen Plus, which was really just a refined version of Zen, as the codename implies, provided on average a 14% boost in gaming performance when CPU limited. Then from Zen Plus to Zen 2, we saw what really is a huge 17% uptick in CPU performance, and the most recent update being Zen 3 provided a further 23% performance uplift. So without question, the gaming performance of AMD's Zen architecture has come on in leaps and bounds with each new generation. That said, you won't always see big performance gains when upgrading your CPU because, as we just saw, you need the right GPU to unleash that additional processing power. So if you're currently using an RTX 2060 or 5600 XT, or perhaps something slower, and your current CPU is a 1600X or 2600X for example, then upgrading to a Core i5 10600K or Ryzen 5 5600X may not net you any additional performance. Of course, this also depends on the games you'll be playing and the desired quality settings, so there is quite a bit to take into account here when selecting the perfect balance of CPU and GPU performance, and what is optimal for you might not be optimal for a different gamer. I suppose we should also quickly talk about core counts, since that came up a lot in the previous CPU/GPU scaling video which focused on the Zen 3 parts. I just want to reiterate what I said in my Ryzen 5 5600X review, and that is that gamers shouldn't focus on CPU core count. In fact, the only real considerations should be CPU performance and how much CPU performance you actually need. I did say in the previous CPU/GPU scaling video that for gaming right now, all you need from the Zen 3 range is a 6-core 12-thread model, but that's not to generalize by saying something like a 6-core 12-thread processor is all you need for gaming, because as we've seen here, 6-core 12-thread performance can mean just about anything, with the 5600X up around 100% faster than the 1600X in the most extreme examples. So again, please focus on CPU performance and get over this core count obsession for gaming. Anyway, that's all I have to say about that. There's plenty more testing to be done, which I'm very excited about. And I'm also keen to add Intel's upcoming 11th gen core series to the mix as well. So I've got to get back to benchmarking. If you enjoyed this video, please do hit the like button. An insane amount of my life was spent creating this content over the past week or so. So yeah, a lot of testing was done. And also, if you'd like to join the Hardware Unboxed community, then you can do so over at Floatplane or Patreon. The links for both of those are in the video description, so check them out if you're interested. You'll get access to our exclusive Discord server, monthly live streams, behind the scenes content, Q&As, a lot of cool stuff. So yeah, as I said, check it out if you're interested. If not, perfectly fine. And I would like to just thank you for watching this video, especially if you watched it 100% right to the end, part of the 20% club. Good stuff. Anyway, I'm your host, Steve. I'll see you again next time.